In our eco-column, we had 3 chambers: the terrestrial, the aquatic, and the sand chamber. Our terrestrial chamber housed our detritivores and our land plants, which ended up being the garden bean and the sunflower, which are our lasting plants that lived. Our aquatic chamber housed our fish, elodia, and hornwort plants. And then our sand chamber acted as a filtration system, and it was just simply sand. Throughout our experiments, we added a couple of adjustments, one of them being stakes. As you can see here, we added stakes to our garden bean. We added the stakes on September 24th to support our plants because it was kind of leaning over because it was too top heavy. The stakes kept the plants from leaning over and allowed for maximum amount of sunlight to successfully reach the plants, thus allowed for a healthy photosynthesizing. As you can tell, the plant looks very healthy. And the plants that were aided by the stakes grew tall. We also had another plant that was aided by a stake. It was the radish, but it sadly died due to detritivores, which is the next topic that I will talk about, which was another adjustment we added. We added 2 worms to our eco-columns. Those were the more effective detritivores. We also had millipedes, but the millipedes ended up eating our plants. The earthworms didn't eat our plants, and we added them on October 4th. The detritivores improved the health of our eco-column dramatically because they help break down decomposing organic materials. As you can tell, we have some leaf litter inside there. And they helped bring back some needed nutrients to the environment. And once we added the worms, we saw exponential growth in our plants, and that was successful. So we can be deduced that the worms made the soil healthier, which then in turn made the plants healthier.
Hello, so these are our 2 chambers which housed plants. We have the terrestrial chamber and the aquatic chamber. And as you can see in our terrestrial chamber, we're lacking in plants at the moment because as time went on, the nutrients in our soil decreased. And the only plant that truly prospered was our garden bean plant. Plants number, I'm pretty sure it was 2 and 1, were eaten by mealworms when we added them because we did not have the proper detritivores. We didn't have earthworms, so the mealworms that we added actually took away from our chamber instead of added like the earthworms should have. And so because of that, we lost plants since the roots were eaten away. And in our water chamber, we have the hornwort, and we have the elodia. And the elodia was added in after our fish Benjamin died. So it hasn't really been affected by a fish eating it. And so looking at the charts, you may see, so this is the hornwort plant length. And so over time, it fluctuated up and down. As you can see, when it went down in the graphs, that was because our fish, Benjamin, was munching on the plants. And then it would go back up because there would be nutrients added into the water, thanks to Benjamin's fertile poop. And then it would go back down and up again as time progressed because he ate and then it grew, and then he ate and then it grew. And then, so our pea plant started off as a wee little seed. So it started off down here with no height because it was a seed buried in the soil. But as time progressed, due to the artificial lights we had, the ample supply of water, and the nutrients from the soil, the pea plant was able to grow. And so in order for us to allow it to grow properly and not fall over the water bottle, we added in some wooden stakes so that it could be properly supported, some pipe cleaners, and some tape to hold the stakes together. And this was very important, and if we were continuing the experiment, we would most likely add another stake so that this plant could continue to grow up towards the sun. Okay, so at the start of our experiment, we were just given plain soil without the seeds, obviously. And so we had to filter through the soil to get out any excess nutrients and make sure that it would be good enough for the plants and not create super acidic water. So what we did is we poked holes in the bottom of this cap and filtered water through many, many times over a couple days so that the soil would start running clear and it wouldn't be all brown and muddy and make our water muddy. And the way we were able to do this and get the water so clear was by the sand chamber. So as you can see, there's a hole in the sand because the water dripped through and the sand held all the excess nutrients, and it actually has a light green tinge because of the moisture. And so this held out any like harmful bacteria and things like that, so that our water would be able to be as clear as it is. So the water we have in our chamber is not the water directly filtered from here. We put in some DO water just to start fresh, but the water we used to water our plants was used from here. So in all, look, we've discovered life. There is a snail. We have a snail. So in all, the filtration we did earlier in the experiment was very beneficial to the plants and fish that, rest in peace, Ben Yemen, that used to be in here. So it produced clean water, and because of this filtration system, it kept the pH relatively stable. So in this graph, we have the pH in the water column over 48 days. And so the typical pH for some good water is between like 6.5 to 7, because that's a pretty neutral zone. So our pH was able to stay this way thanks to our handy dandy filtration system.
As you can tell by our graph, our DO fluctuated a lot, and the reason for this is relatively simple. We see a plummet about here, and that is when our fish Ben Yemen died. And the reasoning for the low impact of this is because the bacteria involved in his decomposition affected the water. But after he died, we added in some water plants, and this allowed the DO to go back up to a normal level and stabilize about right here. But the experiment ended fairly soon after that, so we don't have a lot of data saying what would happen later.
5 questions.
After analyzing the EcoColumn, we came up with 5 questions. Here they are. When starting the EcoColumn, we used generic potting soil. Would using soil collected from areas around the school campus make big differences in the plant's ability to grow successfully? Does selecting a wide variety of plants for the EcoColumn terrestrial chamber make a difference in the soil quality? The EcoColumns were kept inside the science lab. If kept outside, would this have affected the water quality or the plant's ability to grow? If the EcoColumns were kept outside, would rainwater have a positive or negative impact on the column as a whole? Would it affect the water quality, bring bacteria, make the worms more active? And if instead of using seeds, we used already started plants, would this affect the results of the soil quality? So this is our EcoColumn. Hopefully you learned something today. Thank you.